So hello and welcome everybody to this session on sustainable energy needs for controlled environment agriculture. A quick thank you to the organisers for inviting us to host and be part of this webinar as part of a wider series for Dcarbonise Week. We've got some great panellists joining us here today, but let's start with a brief introduction to me. My name's Mark Haller. I'm the founder and chairman of UK Urban Agritech, or UKUAT for short. We are an industry association that brings together the leading players in the controlled environment agriculture and urban agritech space in the UK. This could hardly be more topical right now. We've all seen a lot of stuff in the news of late about energy and about food. There's a lot of thinking going on in policy circles. It's all sorts of interesting reasons that now is very much the time to be having this conversation. But before we dig into that, I guess we'll start with a round of introductions to our wonderful panelists. So arbitrarily, I will start with Doug, if I may.
Hi everyone, I'm Douglas Elder from Intelligent Growth Solutions based in Scotland. I head up our pre-sales function for IGS, which is basically about connecting customers to the right solutions within IGS and also making sure IGS has the right solutions going forward. IGS is a vertical farming company. We develop the technology for growers to use a fully automated solution, which is designed to be scalable, modular, and sustainable. With that, I'll hand back to you, Mark.
Okay, thank you very much. Nice and short and sweet. Ahmed, I'll come to you next, if I may.
Yep, thank you very much. Hello. First of all, thank you very much for having me. This is Ahmed, CEO and founder of Brit Energy. Brit Energy was formed back in 2017 when 2050 net zero target was announced by government. We have been developing data-driven solutions to reduce cost and CO2 associated with electricity used by commercial and industrial consumers. And most recently, over the past 18 months, we have been engaged with like of IGS to understand the demand and how we can supply energy to them at an affordable and clean way. Thank you very much.
All right, brilliant, thank you. And that leaves Charlie.
Hi everyone, yeah, real pleasure to be here. So my name is Charlie Guy. I'm one of the co-founders and manager director at Let Us Grow. So Let Us Grow is an indoor farming company. We work in both vertical farms and greenhouses, developing solutions for growers in the UK and around the world for growing in a more sustainable way and in a more local way. So yeah, my background is in renewable energy. So this webinar especially is, I guess, directly linked to all of my interests, bringing together both the food system and the energy system and looking at how we can provide both energy and food in a more sustainable way for the future.
All right, brilliant. Well, thank you, all three of you, for agreeing to be here today. I'm really looking forward to digging into the discussion. Now, on that note, obviously, as I say, we can hardly not address the elephant in the room. Energy prices are much in the news of late, as is carbon with the approach of COP26, of course, and food as well in the form of various policy initiatives. So, generally speaking, vertical farming and CEA, controlled environment agriculture, more generally, tends towards being quite energy intensive to varying degrees, depending on how intensive that system is. So how important is it that we decarbonize that energy use, and how do we best go about achieving that kind of decarbonisation while still maintaining the necessary level of commercial viability? And maybe Doug, I'll start with you here, if I may.
Yeah, I mean, this is absolutely critical, Mark, and as you say, it is the elephant in the room, and it's something that when we start replacing sunlight, that we have to justify the reasons for doing that. I think the misconception with vertical farming and TCEA is that obviously it is very energy intensive, but so is traditional agriculture and glass houses, that whilst sunlight is often free, it does come at a cost. And that cost is, removing energy from these glasshouse environments or diesel tractors, huge amounts of energy inefficient machinery required to be able to utilize that. So what we have the ability to do is effectively take the much more sort of engineered approach to food production in these sorts of environments, and actually start removing things like wastage, which comes at a cost as well, effectively an energy cost in those environments. So if we can start having more grow to order type products, and effectively reduce that energy from the waste market, as well as then ultimately having more efficient technologies, we can start to offset that balance between effectively the kilograms per kilowatt hour, which I think is one of the key metrics for any industry that's doing food production. And it's getting that balance right. And there's a number of ways of doing that in terms of more efficient technology, better yield outputs, less wastage, and ultimately trying to combine all of those factors together to come up with something that is actually as energy similar as other production mechanisms.
Okay, and Charlie, do you agree with that? Anything to add there? Do you think, you know, is it more about the sort of the energy efficiency, or is it something, there are other areas that we ought to be thinking about in terms of decarbonising this?
Yeah, I think Doug sort of hit it on the head there, really. Like, there's no point, in my opinion, of growing crops in a way that is more energy intensive in terms of at the point that you're growing them versus the whole production chain, which is what you've got to consider when you're looking at comparing, say, produce grown in the UK in an indoor farm or vertical farm or a greenhouse versus produce that might be shipped or flown in from somewhere else in the world at certain times of year. So we really take a very much a holistic view of this, that those metrics that Doug talks about, CO2 equivalent per kilogram of produce, you've got to be looking at it with a really that full holistic view. And something that we do here at Let's Grow is full sort of life cycle assessments of our systems. So we know the full picture of the environmental impacts beyond just the carbon impacts as well. And that's something which, when you look at grid decarbonisation, we're seeing absolutely huge impacts. When we look at models we ran in, looking at the 2017 grid mix versus where we are in 2021 versus where we're expecting to get to with more and more renewables on the grid, this is what's really turning the dial in terms of the sustainability of these sort of growing systems. So you've got to factor in everything from the energy that goes into fertilizer production and the drastic amounts less that we use in controlled environment systems versus traditional agriculture, to all of the energy used in transport as well. So I guess on that, the biggest thing for us is about these systems are very measurable. We know exactly what's going in, we know exactly what's going out. And that's where you've got to start with when you're looking at sustainability. Like, we can measure everything, so we can therefore compare against existing solutions and make sure that what we're doing is more sustainable.
Okay, thanks. And Ahmed, I guess you're coming at this from the other side, if you like, the other side of this equation, from the energy side. But Charlie mentioned there a couple of things that I wanted to pick up with you. First was obviously renewables and how much potential you see in those for this industry, and I guess in a wider sense, but particularly focused on this industry. And then secondly, this question of like it being measurable, because this is something I think we're going to come back to again and again. You know, what potential do you see there from the energy industry perspective?
Yeah. Firstly, I should say what Douglas and Charlie said are absolutely correct. And I quite like the way that Charlie put it into perspective, that it's not just about CO2, it's the whole life cycle assessment. So it's other elements such as water and other key criteria when we look at the impact. And obviously, as everybody knows in this panel, that there are numerous amounts of advantages that we can talk about in CEA environment. But if we purely want to rely on grid as a source of energy, obviously there is a mixture of generation, which it does carry CO2 with it. And as Charlie said, there has been significant improvement, whereas I think in 2017, it was around 300 grams per kilowatt. We are now looking at around 150 to 180 grams. So it's a significant improvement. And it's going to be better going forward. So there is a lot of push to introduce renewable into the grid, but as we know, it comes with its own cost of balancing, because it usually generates at the time that the demand is low. And I think when we were looking at the market in 2020 as a result of plunge in the demand caused by COVID. National Grid had to pay around £1.6 billion to balance that shortage of demand, and that is a new market which is forming as a result of introduction of more renewable, where itself is having an emerging market around flexibility of demand, where on a different levels of National Grid and DNO there are new programs coming up which allows those operations where they have flexible demand to participate and generate revenue. And interestingly enough, CO2 of the grid follows the price point of the peak time and off-peak time. So if there is an opportunity to shift demand from peak time to off-peak, you're not just generating revenue by participating in demand-side response program, you're also avoiding high cost of energy as well as the energy which would have come at a high CO2 price. So that market is growing from energy point of view, and then obviously there are opportunities to be exploited by of CEA, where it has a really good granular control and monitoring in place. But that said, it all comes back to the financial viability. So how affordable we can source the energy from renewable. And that's where I think there will be a lot of cross-industry collaboration and innovation will take place. And we are not just only looking at an integrated energy system with CEA operation, we are also looking at integrated business model where we can see that new businesses are coming up. They are not just producer of fresh fruit or fresh vegetable, they are also energy suppliers in that mix. So it's a new business model as well as new technologies which are coming up.
Excuse me. Yeah, I mean, that's a really interesting point, because it brings me on to what I wanted to ask about next, which is this, on the one hand, you've got this kind of question of business models, and on the other hand, you've got what's often at least perceived to be a long-lasting challenge with renewables, which is what might be called the sort of intermittency problem, right? That supply is not consistent. So, I mean, Doug and Charlie, and whichever one of you wants to go first, but how much potential do you see for sort of TCEA type environments to address that bridging that gap between the sort of successful business models and acting to aid this intermittency issue in the energy market?
I mean, there's a huge amount of opportunity here. The fact what we are looking at effectively is a plant is a living battery. At the end of the day, it's storing energy, it is holding that energy, and so there are times where we can switch the lights off or switch the power off in general, and the plant will hold that. It will recover from that. It's not ideal for the growth. You're not going to get optimized growth, but the value of doing that over the value of what we're aiming to do out of the plant, I think, speaks for itself. So it allows us to have a much more sort of dynamic approach to the power and plant relationship, and using the advantages of these crops themselves to hold that energy, to give us, basically make us an asset and not a burden on energy infrastructure, and be able to deal with these short-term power interruptions. Now, obviously that is not, we can't do everything a battery can, but again, you can look at bringing and integrating battery technology, but reducing the requirement, I think, is important on that. And that could be, just a reduction in the power use or a total switch off, but being able to do that dynamically, very, very effectively, sub-second responses is perfectly feasible in these kinds of environments. And that in itself, as a predictable power user, becomes of massive value to these supplies.
Yeah, I think this what was, I guess, a few years ago, the concept of plants as batteries is now becoming much more of a reality. I think when it was first sort of talked about a few years ago, people would say that's a pretty ridiculous thing to be doing. But you, as Doug just touched on, plants do have a level of redundancy, which means that you can, although from a total productivity point of view, you might not be getting quite as much out of a facility, you can look at optimizing for cost instead of optimizing for total output. And that's where the gains can be made, because we all know that renewables, when the wind is blowing and or the sun is shining are the cheapest electricity we can get. So if we can use the cheapest electricity and the most sustainable electricity, then why wouldn't we? And that's where, yeah, it obviously flips the equation when you look at your sort of sustainability factors and also your cost factors of running a controlled environment facility. Energy is one of the biggest impactors for both of those. It's very much aligned with our current grid mix. So to be able to run a facility off of renewables and address that some of the negatives that come with intermittency, aka having to dump energy into the ground when there's not enough demand to actually soak it up in the grid. If you can combine all three of those benefits together, then it makes absolute sense to be using that electricity for growing plants.
Yeah, okay. I mean, I just wanted to, I guess I'm going to throw out a bit of an open question here, but to all three of you really, but I've heard this talked about in sort of two different ways, this energy question. One is the kind of what Doug was talking about, the kind of sub-second responses and those kind of approaches. And the other is a much broader arc that sort of goes over periods of days or even weeks or months or whatever. So, I mean, to whichever one of you, if you have ideas about this, but I just wonder, are those two separate things with two separate approaches, or are they parts of a wider whole? Do they fit together? Is it the same approaches or is it something different?
I guess if I may, we Brit Energy, we have conducted a feasibility study last year around this subject, and the conclusion was that we can actually reduce the total cost of electricity by up to 45% and CO2 close to 100%. But there is a but in there where we, in order to access all of the flexibility available in these operations, you cannot just rely on grid. So you would need to have on-site generation to a certain degree. And when you bring on-site generation from financial viability point of view, you are introducing complexity. So then once you have the right on-site generation and a storage capability, matched with the demand flexibility and the operation and all of those elements that Charlie and Douglas mentioned, then you would be able to maximize the value of that flexibility. And by having an on-site generation and a storage capability like battery, as well as the plants to store energy in them, you would then be able to access different levels. So the ones that Douglas were talking about firm frequency response, which is basically more of a real-time response to the grid's constraints and opportunity. That would very much dependent on the capability of the facilities. So technologies like IGS are using are well capable of participating in those type of demand side response programs. But there are more of a seasonal ones where you talked about, which then what will happen, the way that we are addressing it is that we do have a forecasting mechanism on, okay, how the market is going to perform over the next season, and then how much performance we can expect from our local generation and storage capabilities. And then we can offer or recommend a demand profile to the operation to say, okay, in order for you to be at the optimum position from energy cost and CO2, you better have your profile, demand profile arranged in this manner. And then the operation can adjust itself for over the season. But that said, all of those opportunities of microsecond and next day and half a day type of advanced notice on the energy side and flexibility, they will all be available. And they can all be also tapped into at the same time.
Okay. Did either of the other two want to add anything there before I move on?
I think Ahmed was covered that excellently. So thanks for that.
Yeah, no, that's absolutely fine. I mean, it does bring me I always like it when someone gives me a good comprehensive answer. That's what we like to hear. I wonder whether there's, because this is often framed, at least in our industry, and I guess maybe this is a perspective thing, but in terms of ask not what you can do for the energy company, but what the energy company can do for you, or vice versa, right? There's got to be that kind of mutual benefit, right? And I'm wondering whether those two scales, those two completely different ways, but sort of parts of the larger picture, can offer a benefit to both sides, because obviously, and what those benefits are, and therefore, whether it's co-location or whether it's working through tariffs or something like that, what the benefits are for each side and how that can be used to encourage more of this, because ultimately what you want is replicability and expansion of that kind of sustainable farming, right?
Yeah, I mean, for me, it's about reducing the cost of operation is the ultimate benefit. I mean, that's really it. I mean, if we can get the cost of power down, it changes the dynamic between what crops we can provide the market at the end of the day. So that allows us to start looking more into the commodity type products that are feeding a wider population and giving the industry, the vertical farming industry, more relevance in itself. So that in itself will then allow us to be at bigger scale and therefore offer more benefits for more of these requirements for servicing both the energy side of the industry as well. So it's kind of mutually pushing each other forward with scalability. But also the stability of pricing, I think, is going to be very important within that. And that's what is still a little bit scary, I think, for both sides that we see at the moment, where things change very quickly. But can we make that more robust as a system going forward by having better collaboration between the two worlds and effectively working together to try and resolve that and balance things out so that you don't get these wild changes. By having a much stronger, robust system.
Yeah, I think that's sort of what Ahmad was, I guess, eloquently putting there, is that the more co-located benefits we can add, the more co-located services, the more robust we can make the system, whether it's adding on on-site electrical energy storage and batteries, or maybe even other storage mechanisms that are coming through in terms of innovations. But the more we can sort of add robustness to the system through co-location, the better it is for everyone. But the greater the technical complexity, because you've got more systems to be managing and keeping in tune. You end up much more like a biological system where you've got checks and balances and different co-located benefits providing different services. And I think that's where you sort of go from the micro project scale, where you've got maybe a farm and an on-site generation and storage, and that's plugged into the grid. And then you sort of zoom out a layer and go, what can we do at a macro scale in terms of working with grid operators and the sort of whole system to think, how can we implement these projects into the wider grid as well? And I think that's where you have to do that. That's when you can sort of develop a model that works, replicate, and then expand in sort of scale. So I think we need more joined up thinking between both the energy producers, the energy consumers, the farm operators, and the technology suppliers, because that's ultimately what will enable the total efficiency to improve.
Yeah, I mean, you kind of read my mind there. Sorry, Ahmed, was there something you wanted to add there?
Well, no, I just wanted to kind of again emphasize on the fact that Charlie concluded that it does require cross-industry collaboration and thinking, because it's not although it does introduce risks, which we have recently seen, that the energy price gone up significantly, and that could put a lot of businesses and business model out of the business. But at the same time, it is an opportunity from our point of view. And from energy point of view, one of the challenges renewable generation or plant has at the moment is to once they set up their operation, they need to go through a process of power purchase agreement so they can sell actually their energy. And what is happening is there is a lot of cost. As soon as you put your energy through the grid, there will be a lot of non-commodity cost, which is the cost of levies and taxes and all sorts of different things to deliver that power. So if this can be co-located, then that's a significant benefit to both parties, because then the farm operator, the energy farm operator, they have the peace of mind that they got a kind of guaranteed demand for the next 10 years. And then the farm, like a food farm operator, they know that they got the availability of the power that they need there. And one good thing is that these type of asset, based on my understanding, is they have the relatively same sort of time lifespan. So they do last between 10 to 15 years, which goes hand in hand. So it does allow that integrated model to work. At the same time, from energy point of view, flexible demand is money for energy companies. So if we can see that, okay, we got a local demand which is guaranteed and it's flexible, then we can provide our surplus capacity at a premium rate to other participants, such as grid demand side response. Consequently, the other thing that could take place is that as we are trying to localize the whole supply chain, there will be talks about EV delivery and EV fleet to deliver the crops to the supermarket or to the customers. So the surplus capacity could also serve EVs. And if it's an EV charging requirement, then the energy company can have a good margin over delivering power at a high kind of fast charging mechanism. So the cost to the farm may be 6 pence or 7 pence per kilowatt, but for the EV charging, there will be a 25 pence per kilowatt. So actually, that could levelize the cost of overall energy much better, and it does enable the business models to work. So having that co-location, flexible demand on site, and being able to address different demands and combine those together is of a huge value to the energy companies and their business models.
Okay, I mean, I'm going to come back to that EV point in a minute, because that was something that I wanted to talk about. But just before I do that, I just wanted to ask you guys, picking up on some of the points you've just been talking about, the question of kind of scale and replicability, right? Is it, I mean, I guess I know the answer to this is going to be a mix of the two, but like, is it going to be more preferable to have a smaller number of much larger co-located facilities, or is it going to be more about having lots and lots of sort of small to medium size units, or is it going to be some mix of the two? And how does that, feed into some of the points you were just raising about kind of, costs and business models and the technical complexity of it in particular, because that's something that I want to come back to a bit in a minute. But yeah, just to sort of throw that one out to you guys and see what you think about that question first.
I've got some definite thoughts on this to jump in on. I mean, it's ultimately at the most sort of high level view of it, the scales of these facilities should be linked to the locality, well, both the renewable energy availability in that area and the, I guess, distance and ease of access to population centres. They're sort of two of the key macro factors you want to be looking at here when you're looking at sizing food and energy systems together. Because as Ahmed has said, you want to be sizing these systems together so that they're providing the right benefits to each other in the food system and the electricity system. But you also want to be taking into effect the fact that we're providing energy and food to people. So how many people are we providing these things to and these benefits to in that sort of in that local region? So that's sort of, when you extrapolate, to that view, it sort of comes back to how many people you're serving and how far away they are and how easy to access they are with sustainable transport. But ultimately, I think we're going to see a more and more distributed system, but we will still see large energy producers such as the big offshore wind farms as the grid sort of develops and evolves over the next few, I guess, years and decades. And it's really going to be about matching the size of the food growing facility to the size of the energy production and the local users of energy and food near that. I'd say that's my summary on it.
Yeah, and I think I'd agree with that. I mean, what this does challenge, though, is the concept of the urban ag element. I think is, actually, can we start looking at energy rich areas in terms of renewable energy rich areas, and unlikely that they are within large population centers typically. So But what we will find in most of those locations is they most likely have an underserved logistics supply chain, but what is going there is likely to be leaving empty. So if you look at places like the Orkney Islands and places like that, huge amounts of renewable energy and opportunity there. You have materials being taken up, food being taken to those locations, but very few things being sent back the way. So do we completely challenge that urban ag concept and actually accept that we have relatively efficient distribution systems for food already? Shipping things up from Spain is not ideal, but it is actually per kilo very efficient. It's not something, there is obviously other costs associated with that environmentally, rather than price-wise. But actually, could you flip that on its head and actually reduce the environmental impact through renewable energy and location with that, and utilizing distribution networks that instead of being from the south of Spain are now coming from the Orkney Islands, and using underutilized distribution networks that were, as I say, were under capacity. So I think that will also ultimately depend on the scale. If you can build a huge farm up in Orkney that's shipping food to London, then that will make slightly more sense than trying to build lots of small farms, which will be typically less efficient in certain core locations. But it will also depend on the product that you're trying to serve, because they might not want to travel that distance. So it is a very complex subject. I don't think there's one single answer, but as Charlie's saying, it's got to fit the case in every aspect of what's being produced, for who, for why, and what is the energy source.
Yeah, and thank you very much, Douglas. I think you pointed out correctly that it's a complex question to be answered, and there are so many different elements which lead to making different decisions, whether you go smaller size or larger size. Availability of energy is one of them, but there could be all sorts of other matters, such as availability of the land, access to transport network and other infrastructure, which could make impact on the decisions that are being made. But from energy point of view, the more centers we have with flexible demand, the better we can utilize them from energy point of view. Because one of the things that's happening in energy sector is aggregation of demand and supply. So if you remember, a few weeks ago we had issue with the link to France, and then as a result the price gone up. So if we have the capability to aggregate demand or supply all around the UK and offer that to the national grid, that could be often a really important asset. So having that localization taken place and having access to that flexible demand is another important and significant, I would say, asset for an energy company to have. But either way, whether the scale is small or a scale is large, as long as we can aggregate and achieve certain level to offer that to the national grid, that present an opportunity for energy sector.
And just to elaborate a bit more as well, I think the beauty of this, though, is that the technologies allow us to have the flexibility to choose the right solution. And that's a great position to be in, that there are a number of ways of answering this very complex question.
Yeah, and just the one point on what Ahmed was saying there is that you've got, I'm not going to say it's easier, but it's different when you look at moving electrons around versus moving fresh produce around. And that's where the aggregation bit is. Again, there's different advantages in both. If you're aggregating fresh produce versus aggregating, I guess, energy certificates. But it just sort of adds again to the complexity of both. If you're co-locating, you've got two different things that you're producing that you're trying to move somewhere. But I think again that where we'll end up, and from what you were just saying, that we can have systems of different scales, and the technology is ultimately scalable from, I guess, the sort of small scale at a shipping container to the hectare scale greenhouses, and that enables us to, I guess, replicate and find the right models that are most efficient for the right locations. I think much like we have smallholder farms and very, very large scale producers, the addition of controlled environment agriculture as a technology only means we'll inevitably replicate that, because you want a distribution of scales of production, because they can offer different levels of flexibility to the grid or to the food system.
Yeah, okay. I mean, it's an interesting point. I mean, listening to you guys talk, I was sort of thinking about this question of complexity, and I just throw this out there again as a kind of open question. But it strikes me that what you're trying to do is introduce some form of complexity, right? So if you're operating at a large scale somewhere way outside, well outside of an urban area, then your complexity might come from that kind of co-location and the energy and these kinds of things. And if you're operating at the kind of the small urban scale, that complexity might come from, I don't want to get too much into this today, but from some of the things like the sort of circular economy ideas, resource flows, networks, that density of the urban environment becomes the complexity. But either way, I'm just wondering whether there are ways, what you're really sort of trying to work your way towards is the same thing, and it has to be defined by what your goals are, right? So from that point of view, whether there's, for example, when we look at something like transport and logistics in the urban environment, that might involve very low, and I'm asking for your thoughts here, but very low carbon methods like, I don't know, bike delivery, for example. Whereas if you're talking about a very large site with a lot of on-site or co-located energy production, you might conceivably have, I don't know, say electric or hydrogen powered vans that are delivering into the urban environment, right? The end goal is the same, and but the complexity and the method is defined by what it is that you're trying to achieve, which is getting, moving things around the system, like Charlie described, right? Okay. I just wondered whether is that a fair assessment, or am I comparing apples with oranges, I guess?
No, I think you explained it well. It very much depends. The ultimate goal is to feed the population in a sustainable manner. But depending on the market, how and the population and the demand in each locality, that would then specify how large and how distributed that you want to have. So I guess the way that you put it, was very, very good way of putting it forward.
I think, unfortunately, to be a bit of a downer on it though, but we're not there yet. We are still powering this with diesel. At the end of the day, it's a diesel distribution network that we have. So there is still elements of that need to be refined. And I say we need to start, what does the future look like? Because we don't know what's going to be best here. Will depend on the technologies that are coming along, but a lot of those are still very, very new and not proven at being replacements for what exists already. And I think we have to bear that in mind and utilize the existing system in a way that works and has been proven to work well, but also be preparing for what the future in the next few years looks like of how we have these distribution models.
Yeah, and I think that comes back to making sure that for all projects that a full, thorough life cycle assessment is done, because we've got to acknowledge that we're operating in a diesel powered transport network primarily still, and that has a huge impact on certain elements of the sustainability of providing food to someone's plate, whether it's driving it home in your 4x4 from the supermarket, or it's like further down the supply chain. So I think that's where we have to look at the sort of holistic, all the way from farm to fork, farm to plate view of things, and just try and make sure that we're using the best technology that are available at the time, which is, I guess, where controlled environment agriculture is coming in and fitting in really well with the energy system, and moving the needle each time we launch a project, so that if it is a urban project, you're pushing the boundary on how you maybe focus on the last mile transport sustainability, or if it's a large scale system, you're making sure you take a leap with grid integration that makes sure that you've got a greater proportion of lower carbon energy going into the system. I think that's where each project that's delivered has to keep pushing the boundaries of what's possible and pushing us towards that more sustainable future.
Thank you very much, Charlie. And what I want to reiterate that agriculture and obviously energy is not the cause of all of the problems that we have with the climate change at the moment. If you have a chance, read this book from Bill Gates, How to Avoid the Climate Disaster, which is a really good book, giving the holistic view of, okay, we got 52 billion tons of CO2 per year and where they're coming from. So agriculture is responsible for 24%, I believe, and there is a certain amount which belongs to the energy systems. The remaining, coming from like of cements and production, steel production, which all has a sort of an impact in what we put together as a farm and as operator, because I believe we are using steel, we are using cement to put the foundation. So there is a much bigger move should take place, and we are part of it. So obviously we are innovators, we in energy, and Charlie and Douglas, they are innovating, their companies are innovating in agri-tech sector, but in order to achieve that ultimate goal of net zero, everybody should work together. Otherwise we can only fix the problem to a certain degree. Once it's come to the point that Douglas is going to source steel and that steel is not coming from green sources, then we are still having impact, but with a much reduced kind of value. But it does require everybody in all sectors to come together and work together. So ultimately, hopefully in 30 years' time, we achieve net zero.
Yeah, I mean, okay, that does bring me on to my next point. I was going to say that I was going to broaden the view out a little bit, but then you talked about 52 billion tons globally, and so I'm going to have to scale it back a little bit somewhat unexpectedly. I guess, you know, we've been talking about the goals here, right? The end goals of producing sustainable systems, and when we talk about all of those kind of things, whether it's transport or food or energy, what we're ultimately the mechanism by which that's delivered is policy, right? And I'm going to stick my neck out here and say maybe, you know, in our industry generally, we haven't yet talked enough about policy, and it's beginning to become a bit of a topic now. So I'm keen to cover that today. But let me start by asking you, from your respective positions of you know, from the food and energy side, what has been your experience? I mean, Doug and Charlie first, from the sort of agri-tech side. What has been your experience of policy so far?
So to be fair, I think it's been fairly limited in terms of that there just aren't any in order to move this along. To be honest, I think there's a huge disconnection between the end users of power and the generators of the power, and I think that's where really it needs better infrastructure to support that, and the necessary policies to help connect the two, basically, between that, you know. And we see transitions in the last few years of them calling themselves distribution network operators to distribution system operators. That's the beginning of that movement, but what does it actually mean, and is it actually being put into practice? So I think there's a responsibility to make sure that the policies that are coming in on the energy side of things are supporting that transition in a way that is actually beneficial. But credit to the energy industry that they have been working hard, the likes of National Grid, etc., have been looking at what's coming next, what do we need to be preparing for the future, and they're giving people the chance to actually input into that. So that's great to see, but it now has to be actioned and actually have the results. And I think there's been limitations in terms of how people have been able to access some of the services. The demand side response services have been incredibly complex and have required huge amounts of scale to be of interest without, you know, far too many middlemen in between that. And I think that's where we need to see easier access being put into that. But the stability, I never want to say we need subsidies for these things, but actually there is times where subsidies will help generate better stability across that to help take the edge off for the consumers of the power and make sure that we are able to implement these systems.
I think on top of that, there's sort of food policy and energy policy haven't really been joined together very well historically. You've got sort of food and farming policies, and I guess the the end of the common agricultural policy, which is sort of resulting in DEFRA and government taking a more holistic view of food and agricultural policy and what that looks like to be fit for the future. But it's still quite separate. I think what's really telling for me is maybe the wake-up call recently, and going back to the gas crisis, of suddenly government having to put in emergency support for energy production or gas production to support the food industry. And I think that's probably joined up a few dots in people's minds where previously they weren't there, and they were seen as disparate systems and disparate areas of policy, whereas actually we need to be looking at these things together, because of how intertwined our food system is and our energy system. So that's where I think the future policy needs to go, and those joined up conversations need to happen. I think the national food strategy starts to pull together some of those ideas and make sure things are being looked at in a more holistic way. But ultimately, we've still got different government institutions, government areas looking at energy and food, really. So obviously recently there's some calls coming out of DEFRA for supporting adoption and also supporting innovation in the sector. But yeah, back to what Doug's saying, I think there's not really well, in terms of encouraging adoption, subsidies could do a huge amount, but they'd have to be smart subsidies, and they'd have to be ones that really look at embedding sustainable systems in for the future, and encouraging systems that can then sustain themselves without policy support when that's removed. But I think ultimately that sort of subsidy support will really help drive some of these innovations, a bit like what I was talking about earlier. If each project pushes it forward further in terms of sustainability and cost of production, then each subsidy has a material impact, or each project that's subsidized has a material impact on improving and moving towards being able to take away those subsidies, if that makes sense. So I think it can be a really, really powerful mechanism, as we've seen in the renewable energy industry, in terms of enabling us to really bring down costs. And the other thing that brings down costs is obviously scale and economies of scale. So you'd hope that a subsidy, sort of a set of policies that may include subsidies wouldn't need to be there for a huge amount of time. They just increase adoption and increase the scale, and that will bring down the cost to the point that we don't need them.
Has that been your experience, Emma? Do you see that disconnect that the two are mentioning here?
Yeah, well, I don't necessarily have a great view over the policies being made in food sector for adoption of new technologies that the like of Let Us Grow and IGS are bringing in, and how they are being supported through that. But from energy point of view, there has been quite a lot of movement going on, and they are trying to make the process easier. As Douglas said, one of the challenges previously were being faced were that the complexity and the different licensing mechanism that you need to have in place in order to access certain opportunities. And then that would put a lot of middlemen in between, where by the time that the consumer get the part of the share of the value, it was so small, so they could not be bothered about the kind of overhead it would have caused. So those are now being removed, and they are being assessed again against the future requirements. But it's not just food sector which is electrifying. There are lots of other sectors which are electrifying in order to achieve net zero, and all of those the policies in energy sector are being tried. I mean, that like of Ofgem and BEIS and distribution network operators, they're working together to see how they're working together with the industry to see how they can best serve the future growth and movement toward net zero by introducing new policies, and also changing some of the current policies which act as a barrier for the sector. But I think it's not just about policy, it's also about what market demand as well. So what signals do we get from the market that would then drive the investment community? So if there are policies going to be introduced where it can help the consumers' awareness on their choices and the impact of their choices on the environment and the local economy, then we're going to get a lot of good signals from the market, which then develop confidence in the investment community to come and invest in a projects that are addressing that. And then consequently, we can achieve that economy of scale that Charlie was talking about. And then it will start to roll over like a snowball, and hopefully we'll just cover all of the areas that would require to achieve net zero. So I think it's not just all about policy, although policy is a big kind of influencer in getting it happen, but we also need those awareness to be increased so we get the right signals from the consumer market. So that's my view on it.
Okay, that's sorry, Charlie, were you going to add something there? No, okay.
No, I think that was a really good addition to add on. Is policy can impact at different levels, whether it's impacting on consumers or impacting on end consumers, that is, an awareness, or whether it's impacting on the sort of financial levers that you might help to adopt. I think that's such a critical one, and I think there's definitely some learnings from the energy industry for the sort of sustainable food industry to take from that. I mean, you look at Octopus, who just raised 600 odd million with Al Gore's fund backing them, and that's a combination of, I'm sure there's been a fair amount of policy support that have facilitated some of that development as a sustainable energy company, but ultimately there's a lot of consumer backing behind that as well.
It's an interesting point. I mean, I guess just to put a thought out there again to see what you guys think, but when we talk about policy, we often tend to talk about sort of national policy, right? And I wonder, listening to that particularly about the sort of consumer awareness, and Ahmad, you mentioned the local economy. Is there the scales of policy from sort of local to regional to national to international, if you really want to get into it? But what do we be looking at them as well to help facilitate that kind of that consumer and market side, because they can be more agile and more responsive compared to sort of national policy, which tends to be this big overarching framework, right? And just whether you had thoughts on which levels we should be looking at and where the advantages of doing so might be.
I think it's a really good question, and I think it has to be involved in all levels. So starting from council, local communities, and to how they how they can influence. And I think that the amount of impact each level can have can be quite significant, and they are all complementary. So we cannot just rely on a national level because there are complexities for national level policies to be implemented, because the impact it might be fair for some participants in the society, but it could be unfair for lots of others. So we need to have that national layers, and then we're going to need those kind of localized policymakers to come in and try to have their influence to their limit, because obviously there are limitations to the level of authority they have over certain things, but it has to be engaged in all of the layers rather than just depending on the single one, because these different layers of policymakers, they could actually act as a barrier for implementation of the policies made in a different levels. So they need to work together, and they need to all be aligned toward a common goal, which is net zero and sustainability.
Yeah, I don't think there's much more to add to that. I think the community food initiatives here locally, for me, I'm in Bristol here in the UK. There's some fantastic local initiatives in terms of engaging people in the food system, which needs to happen, and engage people in the energy system as well. And I think that's where the community piece comes in, and the power of local communities is really strong in that sort of the consumer driven side of the picture. But that needs to be aligned and linked up to sort of regional and national strategies. I think you guys will probably be aware that sort of Wales has recently published a I guess, their strategy on controlled environment agriculture, and that's ahead of, I guess, some of the others. I know that Scotland are looking at their strategy on controlled environment agriculture as well. So there's the different sort of regional impacts, and they each have different different levels of authority, like you say, Ahmad, and different abilities to impact on the system as a whole. But I think it starts really at the community level of engaging people with our food system, which is where local policy can have a really, I guess, can punch above its weight in terms of the impact.
Yeah, I mean, you see initiatives quite regularly in food enterprise parks and things like that, but these need to be food and energy enterprise parks. You know, we need to be looking at it holistically about addressing those challenges and making sure that's all being integrated into that.
Okay, brilliantly done, Doug. You brought me just nicely to the last question I wanted to ask you guys as we head in towards the hour. And I guess I'll ask each of you in turn on this one, because I just want a bit of a sort of overview summary, because right at the beginning, I think it was Doug mentioned that all food production requires energy, right? So ultimately, when we're looking at kind of sustainable food production and sustainable energy and all of these kinds of questions, I just wanted to ask each of you for a sort of an overview of how you see this fitting into the bigger picture of food production. How does it, I know we could probably go on for hours about this stuff, but like, how does it fit with other forms of food production and energy use, whether that's from direct production or kind of fossilized or whatever else? But, you know, just a sort of, brief overview from each of you. And I'll start with Charlie, if I may.
Yeah, thank you. I'm not sure how I can summarize such a big topic, but from my perspective, the food system is a subset of the energy system. And ultimately, to solve the environmental problems that we need to solve the sort of total energy problem. So yeah, it really comes back to a lot of things we've already talked about in terms of joining up the thinking, the conversations between different actors in the energy system, and that the energy system for me includes the transport system, it includes the food system, includes, I guess, our electrical energy systems as well. And that we need to acknowledge it at that macro level to be able to have the impact that we need to. So yeah, I think I'd say my sort of take home message is more around that, reflecting back on the joined up thinking and cross collaboration that we need to have between the different parts of our energy system, of which food is a subset.
Okay. Doug, I'll hand it over.
Yeah, no, I mean, that's Charlie's spot on. I mean, what we've been looking at, obviously, we're looking at a lot of new crops. Where can we take this technology? What can we do with it? And there's, you can literally do anything with this technology in terms of growing things. But should you is the real question. Actually, where we have food systems that are working very well, we make them better. We optimize those, not with, and that this technology that we're developing might be part of that. We might get better starter material and optimize the processes that are put into those to make those more efficient. And that might be, things like brassicas to offset the transport of bringing loads of plants up. We offset that, and that allows us to grow locally and do these things for broccoli growers, stuff like that. That's a great use case, but geography is everything here. And it's looking at what is done well, what can be improved, what can be optimized, and what actually are we just doing really badly as a food production system that we should stop doing immediately. Just, and switch over to new technologies, which may or may not be vertical farms, or it could be traditional glass and more sort of optimized traditional glass. But I think we have to look at that sort of approach and across the board of food production in the UK market and globally as well, and start seeing then, okay, what can be done to optimize those in terms of the integration of that. And it does start by collaboration, absolutely. And that's collaboration between traditional food systems, energy systems, and new innovations coming into that.
Brilliant, thank you. And Ahmad, I'm interested to hear your perspective, having had this conversation, and whether you echo those ideas.
Oh, definitely. And I think from looking at it from looking at the larger picture, from energy point of view, there is a lot of opportunities within localization, which can be realized by integrating the needs of the supply chain from energy point of view, and address them in a kind of a systemic manner rather than silos. And we have been seeing this in food production system, like introduction of anaerobic digestive systems into traditional farming. So those systems can actually produce enough electricity or energy for a complementary offering, which could be vertical farming, which goes to the same place. And then the surplus power could be used to kind of support the EV fleets. So yeah, I should say 100% I'm in agreement with what Charlie and Douglas says, that these could actually come together. And if we have that global holistic view over what is the energy requirement of each of these operations and how we can stack them together in order to increase the resource efficiency and effective usage elements of the assets that are available, then that can bring significant value forward, which could consequently reduce the cost and enable these whole arrangements to work. And obviously, sustainability and avoiding climate disaster is a given within these arrangements. So I think that holistic view is quite critical, and we have to utilize that as much as we can, because that would definitely have impact on resource efficiency, which is quite critical to bring the cost down.
Okay, brilliant. Well, listen, thank you all of you. I mean, my takeaway message from today is definitely that complexity and integration and joined up thinking and getting out of silos is definitely going to be the key to addressing a lot of these challenges and solving a lot of these problems. So I'm very grateful to all three of you for obviously taking part in that kind of conversation. Thanks also again to the organizers of the event for bringing this together. It's a rather brilliant idea. So yeah, thank you to you all, and we'll leave it at that.